Shut up and sit down.
Well, hey everybody, welcome back to our Patreon series where we talk about the National Electrical Code, the 2020 edition. My name is Paul Abernathy, your host, as always. And we've worked our way up through Article 90, 100, and we're in 110, and we're at Part 4. So now we're going to start moving into some of the areas that are the more popular areas of 110, dealing with arc fault current and available fault currents and working clearances and all this type of stuff. So without further ado, let's go on and jump into the material. So here we look at the National Electrical Code. Again, this is the 2020 edition. And what we see here is we're going to start at 110.24 where we left off at the previous edition. And we need to talk about available fault current. Now, available fault current is a condition where from the transformer's secondary point into a building, we have to account for this available fault current because we have electrical equipment like circuit breakers and enclosures that have ratings, okay? Whether it's a short circuit current rating, SCCR, or interruptive rating. I don't know why I started to say instantaneous. An interruptive rating, IR rating, that is all bound, as you saw earlier when we talked about 110.10 and 110.9. So we have all this equipment that we need to know what the available fault current is at these certain nodes on the electrical system. So that, for example, it's most notoriously at the service equipment. But again, the code has expanded other areas in the National Electrical Code, like industrial control panel applications, things like that, where we need to know what this available fault current is. Okay, so we've got some field marking requirements. And then, of course, we have something that's probably not followed very often, and that's called modification requirements. Okay. Now, the National Electrical Code is not retroactive. There's many things in the code that's starting to feel retroactive. Okay. Like now in the 2020 code, surge protected devices required on 1 and 2 family dwellings. Even if there's a service change, you got to add it. And of course, we've had for years, if you replace a receptacle in a location that requires AFCI, then of course it's got to be replaced with the AFCI protection. So you've seen some of these changes that go through the National Electrical Code. So again, modifications is something that people need to grasp because this is something that's an ongoing thing. Even after the installation is completed and it gets a certification of occupancy or allows people to move in and continue on, there's maintenance things that really need to be considered, okay? So anyway, let's kind of look at it. So we're at 110.24. This is available fault current. And we're at A, and that is field markings. And it says, okay, service equipment at other than dwelling units. So this is not applying to dwelling unit application. Now, remember though, this does apply in a multifamily building where the service aspect is probably not going to be a dwelling unit, obviously. The dwelling units are separate, okay? So I didn't want people to get confused. Obviously, this is easy when you're dealing with 1 and 2 family and understanding this concept. But we have to remember that we're not dealing with the dwelling. If it's a dwelling unit and it's a multifamily building and it ends up being a commercial building that has multifamily dwellings in it, it's not applying to the dwelling unit application, and they're typically not going to be service equipment. It does apply back at the building's main commercial equipment, things like that. Okay, just things to remember as we go through this and how you apply things. So it says service equipment and other than dwelling units shall be legibly marked in the field with an available fault current. Now, this available fault current can come again from the utility telling you what it is from the secondary of the transformer down to the service equipment. But in many cases, you might have to do the math. And of course, there is apps on your phone that you can use. Cooper Busman makes a great app. As long as you know the distance of wire, and as long as we can get the available fault current on the secondary side of that transformer, which you should be requesting from your utility, okay? And if you don't know, we typically would use an infinite bus setup, but you can get this information from utility. You just have to request it. And many jurisdictions will require that that information is submitted to them before they move on with the project. So there is ways to get that, but that's a starting point. Now, remember that as the wire gets longer coming into a building, that available fault current starts to drop because of the impedance that's involved in the wire. Okay, so as it gets further into the building, the values of the fault current will start to drop as you move through the building. And that's not such a bad thing. Obviously, the less energy, the less potential hazard it is to everybody. But the reason we need to know the available fault current is because we need to know that if I have a fault at that node in the system, let's say at the service, can the equipment handle it? Can the overcurrent protected device handle it? Because that has its own interruptive rating. And all of these things have to correspond. Okay, so that's why it's required to do the marking. And so the electricians got the task of making sure that they do the fault current calculation all the way at the point where the code requires that that calculation gets made. Okay, and in this case, we're specifically addressing service equipment. Okay, now it says the field markings shall include the date that the fault current calculation was actually performed and shall be sufficiently durable to withstand the environment that's involved. Again, so many people underestimate this concept of I'm putting the service equipment outside, but I'm putting a label on it that's going to be subjected to temperature changes, moisture potentially, humidities. So I have to make sure that label is going to endure. And so it's real important to think about the label. I've been to jobs where it's just been an inkjet, okay, and it's just not going to work. Over time, the ink's going to fade on it. It's going to, all those things are based on the environment where it's located. So it's important to make sure that it's designed. Now, I use a lot, and when I was doing a lot of this, phenolic labels. Those are the plastic labels with the etched into it. That's not going anywhere, and things like that, okay? But you really need to think of that environment. Now, it says, the calculation shall be documented and made available to those authorized to design, install, inspect, maintain, or operate the system. So again, once the calculation is done to determine what this available fault current is at any point on where the code requires this to take place. And in this case, we're talking service equipment. That calculation needs to be available. Now, that's the good thing about using apps like the Cooper Busman app or whatever on your phone. And I don't have a problem showing you that. I'll just kind of pull it up on my phone and let you see what it looks like. It is a free app that you can download. And it's basically just on your phone, and it's a Cooper Busman app, just like that. And it allows you to pick whether it's single phase, and we'll just do single phase. And see, it says add to the system. You simply add to the system, and it said add a transformer to the system, and add conductor runs to the system. So if I already know the transformer's available fault current, then you see how the app will actually tell you, and I could have shared this on the screen, but it wants to know what the available fault current is line to line, and this is usually going to be at the secondary of the transformer. And then you can put the voltage, you can put everything down here, and the length of the run, the number of conductors per phase, the conductor size, copper, aluminum, everything like that. And it literally will give you a printout that you can print out and you can keep in a safe place, maybe in the maintenance facility room or whatnot. That'll tell you what the available fault current is and how you calculated it. Now, again, this statement allows the electrical inspector to request that, okay? Now, there is an informational note here. It's just, again, pushing you towards safety, talking about NFPA 70E, which is the standard for electrical safety in the workplace. It's a very important document that many people take for granted. It really doesn't apply too much to 1 and 2 family applications, although the safety requirements are still there. More commercially driven, obviously. But it is a document that does do different things. And of course, again, like it says here, it says in the informational note, it says the available fault current markings addressed in 110.24, which we just talked about, is related to short circuit current and interruptive ratings of equipment. And I just kind of alluded to that in 110.10 and 110.9 as I talked about it earlier. All these things work together. You have to know what that available fault current is to know how that piece of equipment is going to react. Okay, so all these things have to be taken into consideration. There is an informational note number 2, which you see is grayed out, which is brand new. It says the values of available fault current for use in determining appropriate minimum short circuit current and interruptive ratings of service equipment are available from electric utilities in published and other forms. Okay, so many of the utilities, again, in jurisdictions that I worked with, all we asked for them was, tell me what the available fault current was at the secondary of your utility transformer. Everything else I could handle. Now, if the utility ran the wires all the way in and up to, let's say, the CT cabinet or whatever, then request that available fault current up to that point, and they should be able to do that. But I'll be honest with you, as long as they tell me what's at the secondary of that transformer, I can use a simple app or simple formula, and I can come up with that value pretty easily and create the form. The good thing about that app, and there's others available, one click and you can email the layout and the scheme to yourself, and then you could print it out. Pretty simple to do. Okay, so just remember, service equipment, this is a requirement. Now, the next thing is important to talk about is 110.24b. This is a modification rule. Now, here's what it says. When modifications to electrical installation occur that affect the available fault current at the service. Now, what could do that? We could have a transformer change. You could have had two different, say we had shopping malls, and they had one big transformer supplying one side of the shopping mall, and they didn't really construct the other side yet. So they sized this transformer, and we sized everything based on that transformer, okay? Then they started a second phase of construction, and they added this second side, this other side of the subdivision. Now they need to increase that transformer because they didn't anticipate the capacity, or they didn't have the bigger one available at the time, whatever the reason. When they change that transformer, they now change the characteristics, and it affects the available fault current at the existing setup that you calculated for that old transformer. So now things change. So we have to be real clear that things get changed, things get modified, and we have to be aware of that. Now, there's an exception to this rule, but in general applications, people that are developing subdivisions, or people that are developing, not so much subdivision, I shouldn't have really said that, maybe commercial development systems, they need to be aware of, as transformers change, that it so much affects the available fault current, and they have to be aware of that. Now, modification rules like this are extremely hard to enforce, right? Because, you know what, once a job is completed and CO'd, everything's done and people start moving in, do people really check these things? I used to tell people this is up to the development owner to maintain this. If anything changes, they need to be aware of that. If I get called in as an expert witness and they did not modify something, but we know that there was a change that caused an accident, these are some of the first things that I'm going to look for, okay, to make sure that they followed modification rules. Okay, so let's see here. Very hard to enforce once something's already been CO'd or completed. So it's a tough one here. It says, the available fault current shall be verified or recalculated as necessary to ensure the electrical equipment ratings are sufficient for the available fault current at the line terminals of the equipment. Okay, so service equipment, for example, it's so important that we deal with everything coming from the secondary of that transformer to the line side of that service equipment, for example. And so that's just a great illustration. If that changes, that transformer changes, then the available fault current can change. If the transformer gets more efficient and its impedance values drop, then it can change the available fault current. Okay, so as transformers get more energy efficient over an older transformer, things have to be updated because, again, it does change. And what we don't want to do is have an available fault current that could all of a sudden change, and now the available fault current exceeds the IR rating of the overcurrent protected device or the SCCR rating of the assembly itself. That's a problem. And so that's the rules here. Hopefully, maintenance teams, staffs, and if you're an electrical contractor and you know subdivision, I keep saying subdivision, if you know this happens in, say, commercial locations, then it's a good opportunity for you to reach out to the owners of the businesses and say, if a transformer changed, have you updated and done any type of additional calculation? And it's a simple calculation. You have the app. All you need is the information from the transformer or the utility, and you can do that really quickly, maybe do it for a small fee and make sure that that is up to date. So that's an opportunity for you to reach out to sites if they're in the middle of construction development, things like that. Just things to think about. We just want to make sure that any changes to the system are not going to dramatically affect the equipment, because that's a safety to you and me. We're working on this equipment, and that's what it's all about. All right. So the next thing we look at here, it says the equipment required field markings in 110.24a, which we just talked about, shall be adjusted to reflect the new levels of available fault current. Again, being a modification rule, very tough to enforce this one, but it's important that you know that the code makes reference to it. Now, maybe this would serve itself better in a maintenance code, but it is here, And this gives us an opportunity that anytime something is changed, as a jurisdictional person who is very familiar with municipalities and working as a building official or different things like that, anytime I have some kind of change in a building, I'm going to invoke the ability to recalculate this available fault current to that service, okay? Because unless that transformer hasn't changed, if it hasn't changed, then nothing should change. You get me? So again, a quick evaluation shouldn't take that long, but if something changed, all you got to do is the calculation again, okay? If you're the electrician that's working on that subdivision and you notice these changes, this is easy to do, okay? Now, important exception to this rule. It says, the exception for field marking requirements in 110.24a and b, which we just discussed, shall not be required in industrial installations where conditions of maintenance and supervision ensure that only qualified persons service the equipment. So what this means is if it's industrial and I have a staff that's going to be around, they're always maintaining the equipment, they're not outside hired, they're a team of maintenance and supervision within the industrial plant or facility, then at that point, they can make changes and modify, and they don't have to update these rules, okay? Now, me as a prudent electrician, I'm going to always recalculate these things to make sure it's safe, but you do have the exception, and it only applies to industrial. Now, people ask me, what's the difference between industrial and commercial? Well, residential is pretty clean cut. The only time that people get confused about residential when you get into 3 or more dwelling units in, say, in a big apartment complex, and they want to think that's still residential, that's commercial. But you treat the dwelling units to meet all the residential rules in like 210.52 for receptacle spacing and whatnot. But you treat the entire complex as a commercial building, okay? So again, common areas, things like that, outside lighting that would be on a house panel, all those things you treat very commercial. In a commercial building, it's generally retail, things like that. The only time that you can bridge over into industrial is if it's a facility that is kind of like a campus that produces something. They don't sell it directly, maybe. They produce it to be sold elsewhere. But this is the industrial commercial facility. Now, again, that's the easiest definition I can give you because the NEC, National Electrical Code, does not define the difference in residential, commercial, or industrial, okay? So you're going to have to work with your local jurisdiction to understand what classifies as an industrial because there are rules in here. For example, tray cables where individual insulated conductors can be installed in a cable tray only applies to industrial establishments. Okay, so at some point, we're going to have to try to work with the jurisdiction to define what's considered industrial, what's considered commercial, and what's considered residential. I think we're good with the residential. I think we know most things are going to fall into the commercial category that's not residential, but then you've got that industrial piece, and you might have your own definition of what you feel as industrial is, okay? I use an example of a facility that makes things, like Ford makes trucks. They don't sell the trucks directly from the facility, okay? They are industrial facility. They manufacture stuff. That's how I paint the picture of the difference between industrial versus commercial, okay? Some kind of service is being directly sold from that application in some way, whether it's a service or it's a product, whatever it is, okay? I could have an office building. It sells stuff, but not directly related to what's going on in the building. That doesn't make it commercial, okay? So in my mind, I have to be able to link all these things together, and hopefully you can link those together as well. All right, so the next one we're going to look at is a term that came to us in a previous cycle, and it kind of wanted to collaborate all of this lockable disconnection mean language together in one location. For motors, lockable disconnects, and things like that, we made reference to the terminology of lockable disconnection means, but we started in the 2017 code really heavily wrapping that around, sending it back to 110.25, and it started earlier in pieces, but it really kind of came together well in the 2017 code. And of course, no changes here for the 2020 code with this, but we do need to understand what it is. And this is 110.25, which is referenced in many places in the NEC. It says, if a disconnection means is required to be lockable open elsewhere in the code, that means when you see that language, it means anytime some other code rule says that something has to be lockable in the open position, then it's probably going to, instead of regurgitating that same language over and over and over again, it's going to say that it has to meet the requirements of 110.25. And so that would send you back here. That's why it's in the general in chapter 1 in 110, general requirements for electrical installations, because it applies very broadly through the National Electrical Code. Okay? It says it shall be capable of being locked in the open position, obviously lockable open. It's pretty self-explanatory there. It says the provisions for locking shall remain in place with or without a lock installed. Okay? So it has to be lockable in the open position. Whether or not the lock is actually installed, it still has to be the ability to be locked in the open position. Now, there's an exception to this rule. It says, locking provisions for a cord and plug connection shall not be required to remain in place without the lock installed. Okay? So these are basically, you have cord and plug connections, and they have a clamshell over it. Okay, and these kind of things. So you have an exception for those type of devices for lockable in place. So as it says locking provisions for cord and plug connected shall not be required to remain in place without the lock installed. So they can come off if you don't need it. Obviously, it's cord and plug. Whereas these other rules, when it's a lockable in an open position, maybe kind of like a breaker lock, it has to be on there and it has to remain on there. Well, with the cord and plug, it's more like a clamshell. It goes over the cord and plug, and you can put a lock on it, but it's not really going to remain in place once it's removed because you got to be able to take the cord and plug loose. It's portable. So that's what this provision is allowing for. But in the general rule in 110.25, it literally means if you're going to do a breaker lock on and put it on a panel, for example, it has to remain in place, okay? Whether or not a lock is on it or not, you take the lock off of it, it still needs to stay there so that the next person coming along can lock it in the on position if necessary. Okay, maybe they're doing lockout tagouts or something like that or whatnot. That's just another use maybe for that application. But there are many places in the code that require something to be lockable in the open position, so you have to afford the ability for that to happen. And it can't just be when the lock is there. It still has to be there and ready for me to use a lock anytime later that I'd like to. You with me? Okay. All right, so now we're moving into part 2, which is 1,000 volts nominal or less, generally the applications that we talk about. And we're talking about 110.26, spaces about electrical equipment. It says access to working space shall be provided and maintained while about all electrical equipment to permit ready and safe operation and maintenance of such equipment. So what we're talking about is the ability to get to electrical equipment safely, to be able to operate it. Now, under that condition, we're going to have some different rules here when it comes to the working space and the height and everything that we need to take into consideration, right? And I'm going to tell you, a lot of the stuff that I run into as an electrical inspector for years in the field was that people don't understand the need for working space. They don't understand the need for the working depth, okay? They don't understand the width that's required. And so after you install it, after you do all this work, then you come along and find out that you didn't meet these rules, and then people tend to get hurt in these applications, okay? So we want to make sure we cover these. All right, first one here, 110.26a, working space. Okay, so this is the physical working space in front of electrical equipment. Okay, this is our ability to work on it, get to it, examine it, adjust it, service it if necessary, do routine maintenance on it. We got to be able to get there. So here's what it says in 110.26a. It says working space for equipment operating at 1,000 volts nominal or less to ground and likely to require examination, adjustment, servicing, or maintenance while energized, okay? While energized. And it's simply taking a voltage reading is still energized, okay? And it shall comply with the dimensions of 110.26a1, a2, a3, and a4, or as required or permitted elsewhere in the code. So there are some allowances in the code that can deviate from these requirements. such as limited working space applications rules, where we saw that come into the code in the 2017 code, like in suspended ceilings or under crawl spaces, where you really couldn't meet the height requirement, but you still got to meet the depth, the width, and all the other stuff. So we have some allowances in the code, but it's saying in general, you have to meet these rules. Now, there's an informational note here again that reminds you about safety. This is all about safety. The National Electrical Code is a minimum safety standard. Okay, so we have to remember that. All right, let's talk about these depth of working space. What are we talking about? This is the space between me and the electrical equipment. Okay, what's the space that I have to be able to safely work in here? Not to cram in here and I've got something behind me that's squishing me in or I'm sliding in between something. We have to have this adequate working space. So what does it say? It says the depth, okay, we're talking depth now, working space in the direction of the live parts. So what that means is if you are the live parts and you're looking at me, this is the working space that we have to maintain, okay? And it says distance, direction of the live parts and shall not be less than specified in table 110.26A1, which you see on the screen, unless the requirements of 110.26A1A, A1B, or A1C are met, okay? So we have some allowances in A, B, and C. And we'll talk about those as well, but we're going to talk the general first, the general rule, okay? Now, it says the distances shall be measured from the exposed live parts or from the enclosure or opening if the live parts are enclosed, okay? So I could have a panel, and I've got live parts in it, but I have an enclosure with a cover on it, okay? We refer to dead front. Then I have some allowances that I'm working on this type of stuff, okay? So you could have switchgear, okay, that has a front on it. Oops, sorry about that. I have a front on it. That's what I'm worrying about, this distance that I'm measuring from it. So if you look at this table here, if the nominal voltage to ground, now if I see a 120 volt application, it's 120 to ground, okay? It's not the 240. I see a lot of students do that on exams and get that kind of confused. We're talking about the value to ground. 240 is from line to line, okay? 480 is line to line. But if 277, 480 would be 277 to ground. You with me? So that's kind of the applications that we have in this scenario. So you've got three conditions that apply here for this distance. You have condition 1, condition 2, condition 3. Now, a normal 120, 240 volt electrical panel that's in a dwelling application, that's going to fall to the 0 to 150. And depending on the condition, it could be, in this case, it's going to be 3 feet regardless of any of those conditions is the minimum clearance, okay? So that's easy to remember for residential. Now, when you start moving a little higher and you're getting to 151 to 600, let's say it's a 277 to ground application, then these conditions are going to kick in and you've got to be aware of these conditions, okay? And of course, you've got applications where it's 601 to 1,000 volts to ground, then you've got the same requirement, and you see the conditions get even broader from that application. All right, so let's look at the conditions real quick. Now, I'll leave this on the screen. Condition number 1, okay, is, let me make sure I've got everything still on the screen. Yep. Okay, condition number 1 is, so use this column. It says, expose live parts on one side of the working space, say where you are, and no live parts or grounded parts on the other side of the working space. Let's say it's just air. There's nothing there. Or expose live parts on both sides of the working space that are effectively guarded by insulating material. Okay, so I could have live parts on both sides, but in that side, there's some insulating material that's keeping it from being in contact. Or maybe I have a wall there with a rubberized compound or maybe a mat on it because I couldn't get the necessary clearance, so they maybe it was the big condition 2, and they said, I can't meet the condition 2, so because I can't get 3 feet and 6 inches, let's say if it's a 277 and 480 application. So they said, well, let me uninsulate that wall. Let me put, let me put some kind of insulating material on that wall. Okay, then that might bump them into an application where they're back to a condition 1, which is 3 feet versus a condition 2. So there's things you can do. So again, in this case, let's just talk about a normal panel and a residence, let's say, and there's nothing on the backside. I've easily got my 3 feet. I'm good to go. That's a condition 1. Now, condition 2 is exposed live parts on one side, which is, say, our panel of the working space, and grounded parts on the other side of the working space. Okay, so this is that working space distance that we have. That could be brick, concrete, or tile wall. They're all to be considered grounded. Okay, other metal enclosures considered grounded because we got to bond all these stuff together. Okay, so we're looking at that. And of course, at that point, I run into a condition 2. Okay, so 0 to 151 volts to ground, still only 3 feet in condition 2. 151 to 600 volts to ground, whatever system you're working with, then it's 3 feet 6 inches to that application. Okay, and so all these type of things, that's condition 2. Now let's look at condition 3. Now condition 3 says expose live parts on both sides of the working space. So I've got a panel. This is really when we have, let's say, switchgear and switchgear, and they're right across from each other. They obviously have both the potential to have live parts. So we run into that scenario there where we end up being in condition 3, right? And that's where we have the same concept as 0 to 150 volts to ground is 3 feet. 151 to 600 volts to ground now, not phase to phase, but to ground, whatever system you're working with, that's 4 feet now. And then, of course, 601 to 1,000 to ground is 5 feet. So only you know the system you're working with, but that's when you're going to work on those working clearances. Now, we have A, B, and C here, and it's important for us to talk about them. Again, we're talking about, we're still dealing with the depth here of the working space. Okay, so the first one says, if I have a dead front assembly, it says, the working space shall not be required in the back or sides of assemblies, such as dead front switchboard, switchgears, motor, or motor side or motor back or sides, where rear access is required to work on non-electrical parts on the back of enclosed equipment, a minimum horizontal working space of 30 inches shall be provided. Okay, so if I have, it's not required for the sides and backs, okay, in these applications generally for dead front, switchgear, motor control centers. Okay, again, it says the working space shall not be required in the back or sides of assemblies such as these. Okay, that's the first rule. And again, we're talking dead front assemblies, if it's a dead front assembly, all right? And most of those would probably have a version that's a dead front assembly. Now, it does state where, and make sure it's really clear, it says where the connections and all renewable or adjustable parts such as fuse switches or accessories are accessible from locations other than the back or sides. So if I have the ability to get to all this other than the back or other than the sides, okay, then I don't need the working space. That means I can get to it from the front, okay, and I still have all those working requirements. Again, this is just for the dead front assemblies, and we're giving you an allowance to not have to have the working space from the sides or the back, okay? Now, if there's an ability to get to parts from the front, such as things like fuses, switches, things like that, okay? And as long as I can get to it other than through the back and the sides. Now, what's important is that it went on to say where rear access is required on work on non-electrical parts on the back of enclosed equipment, okay? Again, non-electrical parts, you have to have a minimum working distance of 30 inches and it shall be provided, okay? So, not to get people confused here, you have your general working space requirement, okay? The depth of it. Now, when you have a dead front assembly, okay, and you don't have a need to get to those renewable parts, fuses and things like that from the sides or the back, then you don't need the working clearance there. Now, if rear is required to get to non-electrical parts of that electrical equipment, then you have a problem because now I need to maintain a horizontal working clearance of at least 30 inches, and that has to be provided, okay? I think most switch gears that I get into are not back and side accessible, so we're really only worried about the working clearance in the front, okay? But this does give you a provision if you're dealing with a dead front assembly. Again, B says low voltage. It says by special permission, smaller working spaces shall be permitted where all exposed live parts operate at not greater than 30 volts RMS, 42 volts peak, or 60 volts DC. Okay, so anytime I have some equipment that's dealing with low voltage. Now, what I really don't like that much about this statement is that, to be honest with you, anything 2,000 volts or less is really considered low voltage. So at least here they clarified where you don't need the working space on certain voltage classes, okay? So at least they spelled it out for us, all right? Now, when we say special permission is always going to mean special permission by the AHJ, and I'm telling you, get that in writing before you don't have to worry about certain working clearance requirements, okay? Just make sure you get it in writing. Typically, special permission is what we're talking about, writing. Next one is probably one of the most popular ones in existing buildings. When people walk in there and they say, wait a minute, I don't have these clearance requirements, or I'm not meeting it. We have some allowances here. So, existing buildings. Now, when we say existing buildings, it's already up. It's done. Okay? A lot of people want to say, well, what if I get CO and then I come back the next day? Isn't it technically an existing building? Well, to be honest with you, it probably shouldn't have allowed you to deviate from the required working clearance before it got a CO anyway. So that really doesn't work. So what this usually applies to is buildings that did not have this requirement for the clearances in a previous time before it was ratified in the code. So they're allowing something to take place that might not have been compliant, or might have been compliant at the time it was built and not necessarily compliant today, or something with a building that's not necessarily compliant today. Let's read it, and it'll become very clear. It says, in existing buildings where electrical equipment is being replaced, okay, it's being replaced because it maybe was put in 50 years ago or 60 years ago, where we might not have had the same working depth requirements. It says, the condition 2 working clearance shall be permitted between dead front switchboards, switch gears, panel boards, or motor control centers located across the aisle from each other, where conditions of maintenance and supervision ensure that written procedures have been adopted to prohibit equipment on both sides of the aisle from being open at the same time, and qualified persons who are authorized will service the installation. Okay? So this one is unique because in those existing buildings, we might have a case where they had 2 pieces of switchgear, right, back to back, and they don't necessarily have certain requirement clearances, but you're able to use condition 2 in this application, but you have other applications that you have to meet. And the reason this one's important, because if you look at the application here, it might be an application where you might have to have 4 feet, okay? Or it might have to be 5 feet, because in this case, here you go, live parts on both sides. That's probably an easier way to explain it. Here, if it might require 4 feet. Well, you might not have had 4 feet at that time. They might not have given you 4 feet. Well, it's going to allow you to use condition 2 for this instead of the condition 3. Now, this is important because this is allowing me to do this in an existing building, but this is not saying that I can skip the working clearances because I don't have it. This is saying, look, if equipment's being replaced, condition 2 working space shall be permitted. Okay, now I can always meet what's in the table, but I'm permitted to use condition 2 when I have live parts on both sides. And in that case, you know, there's nothing that says you can use condition 1. There's nothing that says you can use condition 3. You have to meet the normal rules, but maybe at the time it was installed, you didn't have these rules, okay? So it's at least giving you the allowance to use condition 2 if you have an application that it's back-to-back application, all right? So that's kind of all this is allowing you to do under this exception. Now, let's talk about 110.26a2, the width of the working space. So we've discussed the depth, and I will tell you this much. For most all installations, you can ignore this A, B, and C for the most part. You're going to be working in these normal clearances for new installations, okay? These exceptions are allowing exceptions. Again, you might have that issue for the dead front because of limited space and switchgear rooms and things like that. You might use A. B, it's just good to know because you don't necessarily have the working clearance on those lower voltage ratings, okay? And instead of an inspector forces it on you. And of course, existing buildings, you got some leeway because usually in things like switchgear rooms and stuff like that, or panel rooms, they might not have given you the clearance you need originally because it wasn't a rule back then. And now you have these rules. At least if it's in one of those voltages to ground that's higher, it's going to let you use condition 2, which is basically going to put you in that middle category, and it might save you a little bit in your application. Otherwise, you might not be able to put a panel or a switchgear back in the location that you're replacing it. So again, this at least allows you to use column 2 requirements. Okay. Now with the working space, we've dealt with the depth. Now we're talking about side to side. Okay. Can we get in there? That's what we're working here. Now, what does 110.26a2 say? It says the width of this working space in front of electrical equipment. And again, I'll remind you, electrical equipment is very broad. Okay. Very broad. For example, even a disconnect for an outside air condenser unit has depth requirements and width requirements on that. Why? Because that is a location where I typically take voltage readings before I start pulling things apart on the air conditioner. And incidentally, if you go riding around your neighborhood, you'll probably see that's probably one of the number one violations you're going to find that you can at least see. Okay? All right. So let's talk about this. It says the width of the working space in front of electrical equipment shall be the width of the equipment or 30 inches, whichever is greater. In all cases, the working space shall permit at least a 90-degree opening of equipment doors or hinged panels. So in all cases, I still have to be able to open it, all right, to 90 degrees, okay? So in this case here, if I have a normal panel, which might be, it goes in between the studs, maybe 14¼ inches, whatever the width is of a normal panel, I still have to have 30 inches. Now that panel can go in any part of that 30 inches. Can go to the left of it, can go to the right of it, go to the center of it, but I have 30 inches that is mine. That is the width of that working space. And that gets maintained out to that distance we just talked about. So it's kind of like I use people to picture putting a refrigerator in front of a panel. You don't do that, but I'm just saying, the refrigerator is kind of a resemblance of the space that's needed to remain empty and free. That's what we're going to work in. That's electrician space, I like to think of, okay? So 30 inches or the width of equipment, whichever is greater. Now, you could have equipment, for example, switchgear, that is 72 inches wide, 6 feet. Well, in that case, that is your width all the way out to the distance we just looked at, okay? All that needs to remain clear, okay? And that is your working space. So next thing we want to worry about is, okay, we know the depth, we know the width, minimum of 30, could be as wide as the equipment is. Okay, now we need to hold, well, how high does that go up? Okay, well, 110.26a3, which is the height of the working space, and it says, the working space shall be clear and extend from the grade or floor or platform to a height of 6.5 feet or the height of the equipment. Now, this is a good time to talk about the power of or. When you see and, it means you have to meet this and that. When you see or, that means you either meet this or you meet this, whichever is the greater in this case. Okay, so from the grade level or from a floor level, and the reason they say it like this because it could be grade on slab, or it could be on a second floor. You have to start from the floor level, or it could be a grade on level and then they add a platform, and so you have to measure from the platform. So we give you all of these variables that you have to work with. Okay. Now it says that it shall be 6 feet or the height of the equipment, because the height of the equipment could extend beyond 6.5 feet, whichever is greater. And then it goes and says, within the height requirement of this section, other equipment or supporting structures such as concrete pads associated with the electrical installation and located above or below the electrical equipment shall be permitted to extend not more than 6 inches beyond the front of the electrical equipment. Okay? Now, one of these things to remember how it says this. So notice it says other equipment or supporting structures such as concrete pads that are associated with the electrical equipment, which means that's okay to have the pad there. And then or in that space there, it says or, okay, or, well, here let's read it here. You can see it on the screen. Such as concrete pad associated with the electrical installation and located above or below the electrical equipment shall be permitted to extend not more than 6 inches beyond the front of the electrical equipment. Okay, so what are we talking about in this scenario here? This means that electrical equipment, I cannot have things that are going to actually extend out in front of my actual electrical equipment that's going to inhibit or protrude into the working space. Okay, so I've got a height that's required, and it's really telling me point blank, and this is so important that we read this again. The workspace shall be clear and extend from the grade, floor, or platform to the height of 6.5 feet, or the height of the equipment, whichever is greater. Now, within the height requirement of this section, that 6.5 feet or the height, it says other equipment or supporting structures such as concrete pads associated with the electrical installation and located above or below the electrical equipment shall be permitted to extend not more than 6 inches beyond the front of the electrical panel. So it can't stick out more than 6 inches beyond the front of that electrical equipment. Okay? It's not saying it can't be there. It needs to be there for supporting purposes and things like that. Maybe I got the raceways coming in or something like that. But I can't have it extend out more than 6 inches. Okay. With that said, there are some exceptions to this rule. And one that most people realize is, okay, well, when I'm talking about the height, I like to first go to number 3 exception when I'm explaining this. Here, meters. You know, you have the meter socket and you have a meter in it, and usually the meter will stick out. Okay, so if we didn't have this exception, that could stick out beyond the equipment more than 6 inches, right? And nothing can extend out beyond the equipment, okay? Because if it sticks out above it or sticks out below it, then it inhibits me getting to the equipment. And it's inside of that height requirement. So picture this now. We have a depth, we have a width, we have a height. We basically have a cube of space that we're developing here that nothing can be in it. Or if something's in it, it's very limited. You with me? Okay, so a good example of this would be, again, let's just jump to exception number 3. It says meters that are installed in meter sockets shall be permitted to extend beyond the other equipment. Okay, meter socket, for example, or a panel that might be next to it, or the meter center. It says the meter socket shall be required to follow the rules of this section. Okay, so the socket follows the rules of this section, has to meet all this, all the requirements on it, width, depth, everything, yeah, and it has to meet the height requirement exception when you're working on it, even though utilities like to say that's theirs, you don't worry about it. It has to meet it. What this is allowing is that socket to extend beyond the 6 inches of this rule. Okay, still has to meet all the other requirements in this location. All right, height requirements, everything like that of this section. All right. Now, let's look at number 2 exception. We're kind of working our way backwards. The number 2 exception is one that I was talking to you earlier about. Okay, usually in an older installation where there's a panel, and maybe there's a panel where there's a low ceiling, or there's a panel that's, believe it or not, put in a crawl space, which might be a dry location, might not have no moisture in there, and it doesn't have the height requirement on it. Well, if it's an existing dwelling unit, for example, and they put it somewhere where there was a limitation of height, and you're doing something, let's say you're going back and you're doing a replacement, okay, and you just can't meet that height requirement. In an existing dwelling unit, here's what it says. In existing dwelling units, service equipment or panel boards that do not exceed 200 amperes, okay, which, to be honest with you, those old ones are probably going to be less than 200 or less. But here, it's anything over 200 is not going to be utilized in this exception. And so it's service equipment or panel boards that do not exceed 200 amperes shall be permitted in spaces where the height of the working space is less than 6.5 feet. So I've been into some older homes where they might have a basement that's, the ceilings are lower, okay, and they can't meet the 6.5 feet. And you're thinking, I normally would not put something here, okay? Well, at this case, this is going to allow you to be able to do what I like to call a like for like. So if I'm doing a panel upgrade and the panel's already there and I don't have the required height, working height, it's say less than 6.5 feet, it would allow me to replace that panel. And using this exception, I'm still going to have the width, I'm still going to have the depth, but I get some reprieve on the height. Okay, and again, that is for existing dwelling units, not for new installations. And of course, exception number 1 was added in the 2020 code. That's why I worked backwards. It says on battery systems mounted in open racks, the top clearance shall comply with 480.10b. So it has its own allowances that are going to be different than this for their applications in Article 480 for battery systems. Okay, so it's just giving you a notice to remind you of that application. Of course, we can click on that if you want to see the difference in that. And basically, you see right here, it says where top terminal batteries are installed on tiered racks or on shelves of battery cabinets, working space in accordance with the battery manufacturer's instructions shall be provided between the highest point of the cell and the row, shelf, or ceiling above that point. So the manufacturers are going to give you their own requirements that you can follow again, okay? So that's your 3 exceptions to the general rule. Otherwise, I'm expecting to have at least headroom of 6.5 feet or the height of the equipment. If the height of the equipment is greater than 6.5 feet, there you go. Then I need it to the top of that equipment, okay? All right. Now remember, we're not talking about something called dedicated equipment space yet. We're talking about me and your working space. The ability to safely work on equipment, that's what this is dealing with, all right? Next we'll talk about is 110.26A4, limited access. Now this one is important because this one came in the 2017 National Electrical Code. And what it did was it did something that we used to allow in duct heaters in 426 for a long time. And that was reduce the requirements, okay, for the working space, just specifically for these applications. Well, when we had crawl spaces and we had attic applications where we had equipment that was installed in, or maybe above suspended ceiling applications, what happened was we had equipment in there and it met the width, it met the depth, it just could not meet the height. Yet the problem was we had to put equipment in there. And so sadly, the electrical inspector had to turn a blind eye to height requirements in many cases. They knew they met the depth, they knew they met the width of it, but they didn't necessarily meet the height of it. But yet you still could get the equipment in there. So they had to come back and say, well, let's take what happened up there for like duct heaters and let's kind of move it here and create something that applies generally through the NEC. And that's where 110.26A4 came to. And it's called limited access. So let's read it so we can understand it. It says, where equipment operates at 1,000 volts nominal or less to ground and likely to require examination, adjustment, servicing, or maintenance. So those are 4 key triggers here. If in your mind, you can ask yourself this question on this piece of equipment. If it requires examination, if it requires adjustment, if it requires servicing, or it requires maintenance, then there you go. Now, interesting enough, I usually tell people to think about a transformer. Now, I know you can go beyond the scope of rationale, but once you install a transformer and you energize it, does it really require examination? Does it require adjustment? Does it require servicing? Mostly not. Does it require maintenance? Usually not. Okay? Well, when it goes bad, it's just replacement. And that's a requirement to have disconnects, and that's in 450, the rules for disconnect to be able to turn it off and lock it and be able to do a replacement. Okay? So, transformers, for example, you got to think sometimes people are requiring a lot of weird things, and you really need to look at the application. So I use this example, even though we're talking about limited access, for the disconnect outside to an air conditioning unit. Does it require examination of the equipment? Yes. I can tell you right now, my air conditioner fails all the time, and it has to come out, and the first thing they're going to check is whether or not it's got voltage there. It's just a basic 101. We're not going to pull apart that unit just to make sure it's got voltage there. They're going to test it. They're going to open up the disconnect, and they're going to test it. So you're examining it at that location. You're not adjusting it, not really servicing it there, but you are examining it, okay, as part of that service call. So then it kicks it into that. So that's why I kind of use that as a great example of needing to have its width and depth and all that kind of stuff, all right? Okay, I just use that as an example. But you really should take a piece of equipment and ask yourself, not the what-if scenario, but reality. Is this going to require examination after I turn this thing on and I charge this system and I walk away? Does it need adjustment for some reason? Does it need servicing? Does it need maintenance? Not could it need maintenance, will it need maintenance? If you can identify all that, then it kind of helps you be able to apply these rules a little better. And the big trigger to this is this. Do you need to do it while it's energized? That's the trigger, okay? Air conditioning unit, I'm checking for voltage. Obviously, I got to do that while it's energized, okay? For a transformer, do I necessarily need to do that while it's energized when I can always go to the first disconnect and test it there? That type of thing. Now, when I'm servicing an air conditioning unit, I need to test certain things while it's energized. You with me? So, I mean, it's different ways to put these little things in a basket. I'm not here to force my opinion on you. I'm just making you think. You need to think about it because, again, the National Electrical Code is not an installation manual. Okay, it's a safety document. We need to think. There are ways that I can make things safe, and there's no need to examine it. There's no need to adjust it. There's no need to service it. There's no need for ongoing maintenance on it while it's energized. If I can do all that while it's not energized, then it makes you think a little bit, right? Okay. Now, let's look at this here. I kind of blew that by jumping in the middle of it, so let's get back to it here. It says, where equipment operates at 1,000 volts nominal or less to ground and likely require examination, adjustment, servicing, or maintenance while energized is required by installation instructions or functions to be located in a space with limited access, all of the following shall apply. Okay, you ready? So, number one, where this equipment is installed above a lay-in ceiling or drop ceiling, if you will, there shall be an opening not smaller than 22 by 22 inches, or in a crawl space where the space shall be accessible opening not smaller than 22 by 30 inches. Now, I can tell you for the crawl space, the 22 by 30 came from the mechanical code industry because that's how they get their air conditioning, air handler units in and things like that into these spaces. We get that opening. The 22 by 22 kind of means that I could go into a normal ceiling tile and remove that tile and I can get there and things like that. So I have minimum opening requirements for that 22 by 22. Okay, so 24 by 24 tile is not a problem. A 24 by 48 tile, not a problem. Again, to get to that space. You with me? Because I can get equipment that I need necessarily to get up there. So that's the first thing, okay? It can't be smaller than that. That's your first trigger. Check. Next, the width of the working space shall be the width of the equipment enclosure or the minimum of 30 inches ever greater. So you still got the width requirement. Nothing changed. So even though I've got the space was 22 by 22 or 22 by 30 to get to that space, once I'm in that space, I've got that piece of equipment, I've still got my width requirement, minimum of 30, okay? Or the equipment, whichever is greater. Didn't change there, okay? The next thing is it says, all enclosure doors or hinge panels shall be capable of opening at a minimum of 90 degrees. So if I have something up there, some enclosure up there, I have to have the ability, maybe it's a disconnect up there, I have to have the ability to open the door at 90 degrees. Can't be inhibited, if you will, okay? And lastly, it says the space in front of the enclosure shall comply with the depth requirements of 110.26A1. So rather than regurgitate that, we have to have the actual working space, okay? So the width is the same, working space is the same. That part of we have to maintain. It says the maximum height of the working space shall be the height necessary to install the equipment in that limited space. So again, as long as I can install that equipment in there, and it's going to be pretty evident if you can get the equipment in there, then it was high enough to install it. Okay. Now, it also goes on to say that horizontal ceiling structural members or access panels shall be permitted in this space. Okay. So in this space, I can have the structural members or access panels that actually are in this space. Okay. That's not going to inhibit my ability to get to it. And we got to be prudent where we install it and things like that. The real key or the takeaway from you and me is that in order to get it into that space, the height limitation was the one that always bothered us. So this is going to allow that not to have to meet that 6.5 feet. It's simply going to be what's necessary for that equipment to be installed in that space. And once it's installed in that space, it is okay if the supporting structures or access panels protrude into that that space, okay? It's okay. Not a problem. But we have to, and that's talking about the space that we're dealing in with the depth requirement, all right? So I've got enough room to put it in. I could have some ceiling members that come down into that space. Okay, that's fine. As long as I'm able to get that equipment in there. Perfectly fine. And again, this is going to apply to above suspended ceilings. This is also going to apply to crawl spaces. So this is where this rule, typically, if I can get the air handler in there now, I'm going to be okay. If I can get it in there, not a problem. All right? Okay. The next thing we're going to look at is 110.26b. We're gonna skip the separation for high voltage equipment on that. And we're talking about 110.26b, clear space. The working space required by this section, which is what we've been going over, section 26, shall not be used for storage. When normally exposed live parts are exposed for inspection or servicing, the working space, if in a passageway or general open space, shall be suitably guarded. Okay? So basically, the working space that we're creating here cannot be used to store things. Okay? Can't do that. Now, it also goes on to say when normally enclosed live parts are actually exposed, say we're inspecting it or working on it, the working space, if it's in a passageway or an open space, then it needs to be guarded so people can't get to it while this is open. Okay? Most of the time, what this comes into play is that people have panel locations, and you got this mythical, not mythical, it's reality, I guess, we just talked about it, this working space, which I always tell people to paint lines on the floor. Okay? Paint the width, paint the depth, and I actually tell people in construction to print on the floor or put a template on the floor that says, do not store in this space, or not for storage, because I don't want people putting it there. Everybody does. Again, this also applies to residential, but how many times do we have people with stuff in front of their panel? Okay? So again, we want to make sure that you don't store things in this working space. Easier said than done, but that's the whole requirement of that application. All right? Well, what we're going to do for this lesson, we're going to stop right there and pick up in part 5, I reckon. I'm not sure exactly what part we're on right now. I think it's part 5. And we'll get up into part 5. That's just the best thing to probably do is to say, what part were we on? Okay, yes, we were on part 4. Sorry about that. So we're going to be moving forward, and we're going to be looking at larger equipment as we move further into this series. So thanks for watching. Hopefully you enjoyed it a little bit, having a little fun with some of the different statements, and let's move on to the next edition in the series.
Shut up and sit down.